Department of Energy, White House, they've got infrastructure up there in Alaska, and they're worried, about this thawing landscapes and how potential erosion of these landscapes might change, and affect infrastructure and the communities.
Welcome to Growing Impact, a podcast by the Institute of Energy and the Environment at Penn State. Each month, Growing Impact explores the projects of Penn State researchers who are solving some of the world's most challenging energy and environmental issues. Each project has been funded through a seed grant program that's facilitated through IEE. I'm your host, Kevin Slyman. For centuries, there have been places on Earth with very cold climates where the temperature rarely rises above freezing. Ice and permafrost have been constants in these landscapes as people moved in and built roads, pipelines, airports. Today, with global temperatures rising, some frozen regions are experiencing a thaw, and there are concerns about what impacts rising temperatures will have on the ground and existing infrastructure. A research team is investigating how these frozen landscapes may evolve because of warming, including how rivers in the region could change and how river erosion and sediment transport could be impacted. Can everyone go around and introduce themselves? Can you provide your name, your title, and a little bit about your work?
So my name is Roberto Fernandez. I'm from Costa Rica. I've been living abroad for 14 years now and working in the realm of water resources engineering with a particular interest in how water erodes sand, mud, how it melts ice, basically how it interacts with infrastructure or with the landscapes around us. I do lab experiments and some field work to try to understand some of these processes.
I'm Anastasia Paloris. I'm an assistant professor in the Department of Geosciences here at Penn State. My research is generally on coastal landscape change. So I'm interested in how a wide variety of environments at the coast change over time, respond to things like climate change. And I do kind of a mix of things, but for the last 7 or so years, I've been really focused on cold environments in particular that are really vulnerable to climate change in a lot of different ways. And kind of similar to Roberto, I do some experiments, but I also do some computer modeling as well as like remote sensing using satellite-based data and some field work as well.
I'm Tally Fisher. I'm a sculptor and a research artist at the Huck Institutes of the Life Sciences, as well as the Institute for Energy and the Environment. I'm part of the SciArt group, and we seek interdisciplinary collaborations with scientists, faculty, researchers to help communicate and represent the scientific concepts and research that they're doing in order to help understand these kind of complex systems and make them more accessible to a wider audience. We've done a number of interactive art installations, for example, the zombie ant installation, which brings the world of the zombie ant to life.
So let's dive into the project. I just want to talk about these cold areas. Can we define permafrost, and can we discuss what makes these areas so unique?
About a fifth of the Earth is either covered in ice or is underlain with permafrost. Is telling that, for many years we focused on some of the, landscape processes, sediment erosion processes, sediment transport processes in, temperate areas. Some people have done work in tropical areas. But any focus on cold regions has been very specific and not necessarily due to basic science. They don't want to answer fundamental questions about how these landscapes change. And now with climate change and people, switching their focus to cold regions, the Department of Energy, White House, they've got infrastructure up there in Alaska, and they're worried, about this thawing landscapes and how potential erosion of these landscapes might change, and affect infrastructure and the communities that live in those areas. So it's a recent, I would say, shift in focus. Not that recent, but relatively new compared to other areas of the world. And why are they unique? They're not as unique as any others on Earth. They're all special. I come from a tropical region, and I love to study tropical mountain rivers as well. But we have, a very good opportunity to try to understand this changing landscapes under the effects of global warming, climate change, and what that might do to rivers, how they might evolve, how coastal shorelines might change.
In terms of defining permafrost, also for those who don't know, so We refer to permafrost as any ground or I guess material that remains below 0 degrees Celsius for at least 2 years continually. So some people will call it perennially frozen ground. The assumption is if it's below 0 degrees Celsius, it is likely frozen. And so that in itself does kind of make these areas unique because you've got perennially frozen ground and now it's starting to thaw, and it can be really difficult to figure out what that's going to do at a larger scale, whether that's to infrastructure like Roberto talked about, or whether that's to like the carbon that's stored in the soil, which is a big concern for lots of people, and how that might contribute to further climate change. And so that, the fact that we have all this frozen ground and it's been there for a long time and now it is thawing makes it both important and interesting as well as concerning to study from a lot of different aspects.
How is climate change impacting these areas? In my brain, right, I think things are getting warmer, so therefore things are either melting or thawing. And is there more to it, or is it really that simple?
I think there might be more to it. There's a recent publication by a group of Italian colleagues, and they started looking at images of these areas taken from satellites and looking at, in particular, rivers with bends, meandering rivers. And when we scoped out this project, we're thinking, there's going to be a lot more sediment, material from the banks and the bed of the river available because it's not longer kind of be glued in place because of the ice, keeping it there, fixed in place. So all this new material is going to be eroded away and these rivers are going to change. What they're seeing is that in some regions, things are getting warm so fast that there's actually time for vegetation to grow. And then the roots of some of these plants actually manage to kind of provide some cohesion to those banks of those rivers. So they're not eroding as fast as we thought. Before we consider vegetation, we thought, well, they're just gonna, erode away. But now there's also this interplay of, okay, if it's fast enough, then vegetation might have time to colonize and try to kind of give some lee room, for these rivers to not change as much. But we don't know. That might be specific to the regions that they focused on. We don't know that this is true everywhere.
Yeah, I would say I agree with that. I mean, that study was pretty recent, and it's hard to know how applicable that's going to be, long term and broad scale. But it's, things are going to warm and things are going to thaw, right? I think we all agree on that. But there's all the other complications of a changing environment. So whether that's vegetation being able to come in, whether it's thinking about how the hydrology of the river is going to change. So how much water is in the river and when does that water come? What's going to happen to the ice that's usually in the rivers? Could that affect the environment in some other way if it changes the time when it's there and the time when it's not? There's impacts on ecosystems that come with that. So there's a lot of factors that will change, and then feedbacks between those factors that make it even more complicated.
Can we talk a little bit about erosion and the erosive processes that occurred during thawing? Can you help me understand what's happening as things thaw and as things start to move? What kind of things are affected and how are they affected?
Specifically in this project, we're looking at erosion of riverbanks. So I'm going to talk about, specifically erosion of riverbanks. So typically in a river where things are not frozen, let's say, so we've just got water flowing in the river and we've got some banks and a bed made up of, sand and silt, and maybe there's some gravel, different kinds of sediments. The sediments in the banks and the bed will move or erode by the river if the river is strong enough, basically, to move them, right? So you've got to have enough strength in the river to kind of move those sediments out of the bank and transport them down the river. When you freeze those sediments in a permafrost environment, you have to be able to thaw the permafrost as well to be able to then mechanically erode the banks. And so it's a little bit of a different process than if the ice were not there in the soil, if you didn't have that frozen permafrost. So then the question becomes, well, if the soil is frozen, how do things erode? But also if the soil was frozen and then thaws, how will it erode after that? Is it the same process as if it were never frozen before? Or is it somehow different? What's the rate of thawing? Is it just thawing from the fact that the climate's warming, or do we think about how the temperature of the river might also change, and that might affect how fast things can thaw? So it's really all about figuring out what's happening in the water and how does that affect its ability to move sediments, whether they're frozen now, used to be frozen, or were never frozen before.
The only thoughts I had as you were talking about this is thinking about, again, rivers with bends, meandering rivers. They tend to have, a shallow inner part of the bend and a deeper outer part of the bend. So they deposit sediments on the shallow part. That's why it's shallow, because the water flows slower on that inside part of the bend and it flows faster on the outside of the bend. So if we start getting bigger sediment input from upstream due to thawing, due to excess erosion, that deposition in those bars on the inner part of bends, regardless of the ambient temperature, is gonna, push the river against the outer bank. So as Anastasia mentioned before, there's feedbacks between the variables. So even if it might not be, just warming that's thawing the soil, the river temperature, and then this, sediment deposition on the inner part of the bend pushing the water towards the outer part will lead to some mechanical erosion, fluvial erosion, just because of the action of water. Lots of interesting things to look at from the erosion point of view and how that all plays out with the hydrology of the river.
As areas thaw, what infrastructure is being affected and how is it being affected?
Anything and everything that's ever been built in these landscapes can suffer, because whatever their design processes are for their foundations, etc., they rely on a resistance from the ground underneath. So airports, roads, they're built on soil that's been frozen for decades, centuries, and all of a sudden all that stuff's going to begin to kind of soften out, and that's going to lead to issues. And now specifically with rivers, if you have communities that have coastal infrastructure or little, docks, little harbors or ports, I don't know how big they might be. If we think about the communities that rely or that live in these landscapes, they're going to suffer. If we think about infrastructure that might be impacted in terms of the Department of Energy, I know there's concern in terms of pipelines for oil, etc. So there's many different components to it in terms of how infrastructure might be affected.
I absolutely agree. It's everything up there, right? Everything is going to be subject to permafrost thaw and the subsidence or the sinking of the land that comes with that. And you can see really terrifying photos of, people's homes going sideways as part of the land sinks and the rest of it doesn't, if you have localized thaw. And then thinking about in terms of the rivers, because we are expecting, we think faster thaw or faster river erosion as things thaw. There are lots of communities on riverbanks as well, right? People establish where the water is. And so, I think it is also a concern, maybe especially around rivers where we do have lots of communities living in these high latitude environments where, rates of erosion could certainly go up and put, their communities at risk as well.
And rivers have, for a given amount of water in the river, they have a transport capacity. So there's only so much sediment they can move. So if we end up having a lot more in the river can just decide to create a new channel. It can jump out of its current channel. That's called an avulsion, and just find a new path, which again could lead not only to landscape changes in those areas, but, to community impacts. I know it's kind of a gloomy view of things, but that's kind of with our current understanding of how rivers work, and how erosion works, just having, less glue in the system to stick sediment in place, and then stuff's just going to move around. So in my head, there's lots of potential changes coming their way, and it's going to be hard, to find other communities with engineers, geoscientists need to come up with, new solutions, and then also rely on the local knowledge. I think these communities have been there for many centuries, and they can be quite resilient, even if they haven't experienced such things. They know the landscape. They're also a good place, a good resource to think about in terms of how they can adapt. But the main message, I think, is that, there needs to be a way to adapt, not to react.
All right, so let's dive into your project specifically. Can we talk about the goals of the project and what you're looking to achieve?
A few years ago, I did some experiments to look at how meltwater channels on ice formed and evolved. Again, if you haven't already figured it out, my interest is mostly on meandering rivers, rivers with bends. And I was looking at these channels in the lab, using small ice blocks. So when I joined Penn State, I wanted, to continue doing that kind of work. And this opportunity with IEE seemed like a good place, to start pushing that along. And then knowing Anastasia was here and Anastasia's interests in permafrost seemed like a good, opportunity to try to not only work with ice, but also start thinking about permafrost. So the goals of the project are to look, at the small, scale processes, if you will, the particle to particle processes that will eventually lead to landscape change. How do particles get eroded away from a riverbank? So we're going to be making, some ice blocks in the lab. We're going to make different mixtures of permafrost, informed, by realistic data, but trying to just kind of think about, all right, what's going to happen if you have water at different temperatures and if you have permafrost composed of different materials. So to start simple, we'll have just ice, then we can think about adding sand of a given particle size, sand grains that are coarse, sand grains that are fine. And then if we want to keep complicating things, we can add smaller sediment and think about how all these things interact. But main thing is we want to first quantify erosion rates of permafrost substrates.
Getting this data, what do you hope to do with it?
I think the first step is to get this data and gain that fundamental understanding that we really don't have right now in the scientific community of how does erosion happen when the banks are frozen. So that's kind of step one, is like, how does this even work? Because we really don't know in a natural system. And then being able to take that understanding of, well, this might be what we expect the baseline to be in present day, and think about, sure, we can complicate things more and we could do lots more experiments and we could do larger experiments and we could do different experiments. But perhaps more importantly, taking that baseline understanding and thinking about how to translate it into what's going to happen in the future, thinking about how resilient or vulnerable different environments might be based on what the permafrost looks like there. And so, at least from my perspective, what I always am trying to think about in the science of landscape change is, what can we learn about how the landscapes behave now, and then build on that to think about how they're going to behave in the future as things change. So that would be it's kind of a big picture, lofty goal that's maybe not super tangible, but we really need that baseline knowledge to be able to even try to get there.
Yeah, and one thing that maybe hasn't been discussed in our conversation is, we've discussed tools that people take images acquired from satellites, and so remote sensing information. There's also people who go out in the field and do different, spend time there taking different measurements. Why do we continue to talk about experiments? Because we can control many of the variables that come into play. So we can really isolate a single variable and understand how that affects the process. In the field, you kind of get what you get. If you have a bad weather, if your instrument's not working, you're out there, you can't fix it, you just got a week or two there or whatever, and that's it. In the lab, you can go back and repeat an experiment, make sure that what you got is not, just random. It's the actual thing. So, and you can control every variable in the process. So it gives us a very good, window into the different aspects of the process, and we can control each one of them to really inform, how people might eventually come up with a computer model to see how this landscapes evolve. So we test all the conditions and come up with some useful information, parameters, etc., for people to use and think about how the landscapes also might change.
An interesting and I think unique component of this is the goal of communicating the information to a wider audience. And one of the ways you want to do that is through art. And so Can we talk a little bit how you plan to use art to communicate about the project, and maybe even some of the work, Callie, that you've done in the past that you've used art to help communicate?
We feel, at the SciArt group and the HUC, that the collaboration between artists and scientists can really kind of catalyze creativity. And by exploring their research and their findings, taking the data and interpreting it in new ways, that could mean sculpture, digital media, interactive installations, we can better kind of distribute and communicate to a wider audience, make it a little more relatable. These are somewhat complicated scientific processes that not everybody might be able to visualize or understand. So by us both observing and perhaps participating in some of the research, we're hoping that can inform an interesting interactive installation. Listening to you talk about the river systems and hydrology and how the landscape changes over time, taking the sort of basic knowledge that you're collecting, translating it in a way that the community might understand what those impacts really mean for them, and then using art to interpret that and perhaps come up with some solutions. There's a lot of community work done by expressing the way the community might be feeling or might be understanding what these processes are that might impact them. Some of the previous work that the SciArt group has done, we just explored the wonderful world of Wolbachia, which is a really fascinating bacteria that has great potential for solving some really devastating infectious diseases. So we learned about how Wolbachia is in over 50% of insects, and created an art installation that not only has the researchers sort of discussing their research, but visually describes what that impact might look like, how many people are affected by these infectious diseases, and how the researchers are taking Wolbachia, injecting mosquitoes, and then these mosquito populations, the infectious disease drops by maybe 90%. These kind of processes are what we're trying to do at the SciArt group, and interpreting them for the public.
Listening to Anastasia and Roberto, I also can hear all kinds of really cool opportunities to use art to help explain it. So can I ask Roberto and Anastasia, what prompted you to think maybe art could be a great way to help communicate this?
So when I was based in the UK as a postdoc, I had the opportunity to apply for a research fellowship funded by the Leverhulme Trust. Historically, Leverhulme Trust, they have early career awards for science projects, but they're a lot more biased towards the humanities, arts and humanities. So I started thinking on how to best pitch to their board, research topic looking at meltwater channels on ice and meandering channels formed by dissolution. So limestone is soluble, and it also forms, little channels. So I was interested in doing experiments in both of those areas. And I started thinking about, how to pitch this. And I came up with this title about natural sculptures carved by melting and dissolution, and referring to erosion as nature's most successful artist. And that worked out. I got the fellowship, and in planning it, it helped me think, right, I should start talking with people who do this kind of work. And when I was in the UK, I contacted a Costa Rican sculptor that's based in Italy, and COVID kind of affected the whole thing. But we had this plan, to come up with this big limestone block that we would put in the library of the university. And we would just start eroding it. And then, students, as they came in their freshman year, would see it change as they also changed during their studies, So I had all this vision about how to communicate the science of erosion, at least to the university community. And then when I came here, at first meeting, I went to IEE related stuff, and I met Tally. I said, ooh, we need to talk, because I'm already excited about these things and they can make it happen. So for me, been thinking a bit more about this, and there's a lot of misinformation there, and people will choose to read one thing or the other and just not believe in one thing or the other. But if they actually see something happening in front of their eyes, they cannot say, well, maybe they can, but I would expect them to be less inclined to denying the science. behind it. So art is a good way to move beyond, communicating an idea or a research finding and letting people experience it. And that's kind of where it lies for me. It lets people experience it as opposed to, reading about it.
What you're talking about are these processes that happen over a long period of time, right? But there are, for example, I'm imagining putting a microphone and listening to the sound of the erosion, right? And having some sort of audio track over potential video that is showing your erosion processes, because you're speeding it up. We don't have to wait all of this time to watch what might happen. I'm imagining audio, visual photographs, and people can actually experience it. You can feel it, maybe. Maybe there's some temperature related process that's happening. You can touch it, you can feel it. And I think you're right. If people are immersed in it and it's not just the data on a page, they may better understand it and think about it in a different way.
Can we talk a little bit about success? What will success look like at the end of the project?
If I think only of this 1-year seed funding grant from IEE, I want to have, enough data that to go two ways. One, to start, writing proposals that would continue to fund more exciting research, but also, have enough that we can also start doing the art component beyond, the small pilot, if you will, that we would be able to put together within this project. So I want to see those two, continue to move forward together. So I guess success would be, we learned a lot from the experience. We have enough to justify more.
Yeah, I agree with everything that Roberto said. I'll just add on. I think, one goal of this also is to maybe help better establish collaboration across our team. And so I kind of feel like we're already doing that. And so we're becoming successful, but, using this year to figure out how to work together, figure out what our interests are, where they overlap and align, and what those future proposals, might look like if we want to keep on in this theme. So I think collaboration is definitely also a part of that in terms of having success, in addition to, of course, the data.
Well, thank you all. Thank you, Roberto, Anastasia, Tally. Thank you for being on Growing Impact. I really appreciate your time.
Thanks for having us. If people listening want to get in touch, it can be found, on the former Twitter X app at Ice Meanders. I'm also on Blue Sky as of this week at Ice Meanders as well. And then if you prefer email, roberto@psu.edu.
Thanks, Kevin. This was great. So if anybody wants to get in touch, I'm just anastasia@psu.edu. Happy to always chat science.
And if anybody is interested in collaborating with the SciArt group, we can be found at the hucksciart.com.
This has been Season 4, Episode 9 of Growing Impact. Thanks again to Roberto Fernandez, Anastasia Paloris, and Tally Fisher for speaking with me about their project. To watch a video version of this episode and to learn more about the research team, visit iee.psu.edu/podcast. Once you're there, you'll find previous episodes, transcripts, related graphics, and so much more. Our creative director is Chris Komlenik, with graphic design and video production by Brenna Buck, and promotional and social media support by Torian DeViro. Join us again next month as we continue our exploration of Penn State research and its growing impact.